Hello everyone. Today we will practice on a few open-ended questions. Let's get started with question number 1. Figure 4.1 shows a ray of light as it enters the side of a plastic block. The ray of light passes from air into the plastic. State how the speed, wavelength, and frequency of the wave in the plastic block compare with their values in the air. The speed of the wave will decrease. This is because the wave travels slower through denser materials like plastic. What about frequency? Frequency is determined by the source of the wave, and it doesn't change when the wave enters a new medium. Frequency doesn't change. Now, wavelength. Since the wave speed decreases in the plastic and the frequency stays the same, wavelength must decrease. Because wavelength is equal to speed divided by frequency. Let's move on to the next question. Show that refractive index of the plastic is 1.4. Let's remember the formula for refractive index. N is equal to sine I over sine R. I is angle of incidence, which is angle between normal and incident ray, 45 degrees. Sine 45 degrees divided by sine R. R is angle of refraction, which is the angle between normal and refracted ray, which is 30 degrees. Sine 30. Use calculator, and the answer is 1.4. Now, let's calculate the critical angle for the plastic. Let's remember another formula for refractive index, which shows the relationship between critical angle and refractive index. We calculated that critical angle is 1.4. 1.4 is equal to 1 over sine C. In this case, C is equal to sine -1 over 1.4. Use calculator and calculate critical angle, which is 45 degrees. Now, let's move on to the question 1b. Figure 8.1 shows the single turn coil of a simple direct current motor. Explain the direction of turning effect as seen by an observer at O. First of all, I want to label sides of coil by letters. And now, current flows from A to B and C to D. To identify direction of turning effect, I need to determine the direction of forces either on AB side or on CD side. That's why I will use my left hand. This is Fleming's left hand rule. Now let's practice. Force, field, current. Let's match. On AB side, current flows A to B. As you know, magnetic field lines go from north to south, from right to left, and my sum shows upward direction. So, force on the left of coil is up. This means that the direction of turning effect is clockwise, because the force on the left of coil on AB side is upward. Let's move on to the next questions. The coil is replaced by an otherwise identical new coil with 3 turns and the same current in the coil. State how the turning effect compares with the turning effect in previous questions. When number of turns in the coil is increased, the turning effect on the coil will increase. A third coil is identical to the coil in first question, except that its resistance is 3 times greater. The potential difference across the coil is the same as the potential difference in the first question. State how turning effect compares with the turning effect in the first question. Dear student, as you know, if resistance increases, current in the coil decreases. If the current decreases, the turning effect also decreases. Let's move on to the question number 2, which is about Hooke's law. Figure 2.1 is a graph that shows how extension of a spring varies with the load suspended from it. Determine spring constant of this spring. To determine spring constant, we can use Hooke's law, which states that force required to stretch or compress a spring is directly proportional to extension until limit of proportionality. In this formula, K is spring constant. So, K is equal to force divided by extension. Look at the figure. Extension is 4 centimeters when force is 14 newtons. The answer is 3.5 newtons per centimeter. Let's move on to the next question. Mark the limit of proportionality and label this point L. Let's remember, what is limit of proportionality? The limit of proportionality refers to the point beyond which Hooke's law no longer applies. So, material no longer behaves in a directly proportional manner between force and extension. In this case, this point is limit of proportionality. Let's move on to the question number 2b. Figure 2.2 shows a car traveling at a constant speed around corner A on a road. On figure 2.2, mark with an arrow the direction of resultant force acting on the car as it travels around corner A. The resultant force, known as the centripetal force, is always directed towards the center of circle. It acts perpendicular to the object's direction of motion, ensuring that the object continuously changes its direction and follows the circular path. Corner B has a smaller radius than corner A. The car travels at the same speed around corner B as around corner A. State how the resultant force changes due to the car traveling around the corner of smaller radius. The resultant force required to maintain circular motion increases. This is because the car has to change its direction more sharply in order to stay on the curve. The more rapidly the car needs to change its direction, and thus the greater the centripetal force required to keep it on track. Let's move on to the question number 3. A car windscreen is covered in condensation. Thermal energy is used to remove the droplets of water. the thermal energy is provided by 3 resistors on the windscreen. Figure 6.1 shows 2 possible circuits for 3 resistors. The 3 resistors are identical. Describe 2 advantages of using circuit B. In circuit A, the resistors are arranged in series, while in circuit B, they are arranged in parallel. In a parallel circuit, if one resistor fails, the remaining resistors will continue to function. This is one of the advantages of parallel combination. But the second advantage is that each resistor receives the full voltage in circuit B. Each resistor receives the full voltage. Let's move on to the question number 3b. Figure 6.2 shows a circuit containing 2 resistors P and Q. The circuit is powered by a 12-volt battery. Calculate the current in resistor Q. Let's remember the formula for current. Current is equal to voltage over resistance. And the voltage across Q is 12 volt. And the resistance of resistor Q is 70 ohms. So the answer is 0.17 amps. Kind reminder, in parallel combination, voltage is the same. The next question is that calculate the energy transferred electrically when the current calculated in BI is present in resistor Q for 5 minutes. First of all, we have to convert minutes to seconds. 5 multiplied by 60, which is 300 seconds. Secondly, we have to remember formula for electrical energy, which is VIT. Voltage across resistor Q is 12, current is 0.17, and time is 300, which is equal to 612 joules. The next question is that energy is transferred from the battery by the electrical current. State the energy stored in the battery. Energy which is stored in the battery is chemical energy. And the next question is to calculate the total resistance of circuit. Resistors P and Q are arranged in parallel, so we will apply the equation for the total resistance in a parallel circuit. 1 over R is equal to 1 over RP plus 1 over RQ. Let's solve. 1 over 90 ohms plus 1 over 70 ohms. Let's calculate it. One over R is equal to 160 divided by 6,300. In this case, R is equal to 6,300 divided by 160, which is equal to 39.4 ohms. So the total resistance is 39.4 ohms. Question number 4. Figure 7.1 shows a barrier at the entrance to a car park. The wooden barrier arm has a weight of 60 newtons, which acts through the center of gravity at the position shown on figure 7.1. Initially, the wooden barrier arm is horizontal. Using figure 7.1, calculate the clockwise moment of weight of the wooden arm about the pivot. Dear students, moment is equal to the force multiplied by perpendicular distance from pivot to this force. To calculate moment of weight, which is 60 newtons, we have to multiply 60 newtons by 1.7 meters. Because do you see that perpendicular distance from pivot to this force is 1.7 meters? The answer is 102 newtons meter. The wooden barrier arm is in equilibrium. The mass of the soft iron bar A is 23 kg. Calculate distance D between the pivot and the joint holding the soft iron bar A. Let's remember two equilibrium conditions. The first one is that the net force acting on the object must be zero. The second one is that the net moment acting on object must also be zero. So we know that mass of bar A is 23 kg, so we can calculate weight of bar A. It will be 23 multiplied by 9.8, which is equal to 225.4 newtons. So, weight of iron bar A is 225.4 newtons. And in the previous question, we calculated clockwise moment, 102. According to equilibrium condition, anti-clockwise moment, which is equal to 225.4 multiplied by D, is equal to clockwise moment, which is 102. So we can calculate distance, which is equal to 102 divided by 225.4, 0.45 meters. Again, sum of clockwise moment should be equal to sum of anticlockwise moments. So the distance between pivot and the joint holding the soft iron bar A is 0.45 meters. Let's move on to the question number 4b. Figure 7.2 shows a coil attached to a power supply placed below the soft iron bar A. State and explain what happens to the wooden barrier arm when the switch in the coil circuit is closed. Dear student, when this switch is closed, current flows through coil, and the coil produces magnetic field. So, this electromagnet attracts iron bar downwards. It attracts iron bar downwards. In this case, barrier arm rotates anti-clockwise direction. Explanation is that when switch is closed, current flows. I'm writing briefly. Current flows through the coil, and the coil produces magnetic field which attracts iron bar. Now, let's move on to the last question. The switch is opened and operator decreases the potential difference across the coil and the switch is closed again. State and explain how the effect on the wooden barrier arm compares with the effect in BI. Of course, barrier arm moves slower because when voltage is decreased, strength of magnetic field decreases. Strength of magnetic field on the electromagnet decreases. That's why the wooden barrier arm will move slower. That's it for today. Keep practicing on the past papers. See you next time.